Many times mentioned, many times described, so let's keep it short. The system architecture or system architecture model focuses on describing the entire system from a structural and a behavioral point of view. I think we know that by now. The architecture shows the structure of the system, its subsystems and parts, as well as their interfaces and relations. In the context of MBSE, the system architecture is typically represented in block diagrams. Besides the structure of the system functions and states are part of this architecture. Each system has several functions to fulfill to meet its purpose, and has different states in which the functions are executed. It is key to success to document this, so the structure and the behavior, the information in the system architecture model, and to share it to the whole development team, the customer, and the stakeholders. Just to bring it to your mind again, the system architecture architecture model is a set of diagrams and views on the system. Each diagram contains various artifacts that describe the system. If required, the artifacts are linked to other artifacts. Depending on the modeling language, not all types of artifacts can be represented on all types of diagrams. So in general, there are certain rules that have to be followed. The architecture is created by the systems engineers, under the involvement, of course, of the discipline-specific engineers who have a certain system responsibility. The information documented in the system architecture model has to be shared with the whole development team, such as the CAD engineer, for example. Defined structural elements, interfaces, and functions have to be forwarded, as well as feedback needs to be collected. Besides the design of the system, before continuing with the more detailed discipline-specific development, the architecture has a kind of steering and management functionality. It allows the systems engineer and project manager to steer and control the discipline-specific development under consideration of the entire system. Furthermore, the later system integration, verification, and validation is supported by the information the architecture contains.